Hi everyone. I've been working on the brain tumor MRI dataset from Kaggle. So this particular dataset consists of brain MRI images and basically has four different classes of cancer. One is glioma, then meningioma, then pituitary cancer, and lastly, cases where there is no cancer at all or no tumor at all. So to begin with, we first download the Kaggle dataset and then unzip it into our Google Colab directory and perform initial exploratory data analysis. And we observe that the data set is quite well distributed and is not skewed for any specific class at all, meaning that this particular data set is well balanced. And we do this for both the training as well as the test data set. Once we done that, we basically visualize some of the images from the data set that we have. For example, there's the class glioma, then class pituitary, class meningioma, and classes and cases where there is no tumor at all. From there, we basically train the exception model on the ImageNet data, ImageNet weights, and use max pooling. Train the model for 10 epochs and use categorical cross entropy laws in order to compute our loss. So we can notice that after training for 10 epochs, the model is doing quite well with around nearly 99% of accuracy, as well as the training loss is still decreasing, while the validation loss is a little bit higher than that, indicating that our model is not overfit. And printing out the results, we notice that the training accuracy we have is 99.7, validation is 99.08, and test accuracy is 99.09 after 10 epochs of training. We also print the confusion matrix and observe that except for a few classes, almost every other is correctly identified. And we perform some inferences for some of the images that we have and notice quite good performance overall. We also train a custom built convolutional neural network model for 10 epochs and notice that the training has been little bit decreased. The training accuracy has little bit decreased compared to the exception model, but it's doing fairly well after 10 epochs. The accuracy for our custom built CNN model is around 98.42 for training. The validation accuracy is 94.81 and the test accuracy is 96.65. And the confusion matrix is a little bit more misclassified classes, but all in all, it's doing quite well. And we also notice that recall is quite good for most of the classes, as well as the precision being 94% or above in most cases. Then we build a Streamlit app. Streamlit app can just open the link. So as we can see, we have a file upload function where we can upload a specific test image, and then we can select our models. The default model selected is transfer learning with the exception model, and we notice that the model has predicted around with 100% accuracy that it is meningioma. And we also provide a saliency map in order to detect what the model is focusing on. So this cyan area is what the model has been focusing on, which is where the tumor exists. And we add some UI components in order to display the prediction class as well as the confidence. And we have also implemented the Gemini. We have also used the Gemini 1.5 Flash API, in order to create AI in order to generate AI generated explanation of what the model has been, what the model has learned. So as we can see now, let's also test for the custom CNN model. Yeah, so the custom CNN models predicted around 99.96, which is quite close to what our exception model has predicted as well. And as we can see, we have the misclassification, or the misclassification is for 0.03%, which is quite less. And it is for no tumor class, but 99.96% confidence. With 99.96% confidence, our model predicts melanoma. And we're just waiting a couple more minutes for the Gemini 1.5 Flash API to generate its explanation. And as we can see, we have the AI generated explanation for this tumor as well. Thank you.